So we were looking onto this code last time. When we were running the code, it was giving some weird output of other module, right? So this was the culprit. Actually, when I was writing down the code, so accidentally this got imported from one of the Python module. So because of that, the output was coming up weird. So yeah, I just wanted to show you this before I start today's session. So I have commented out this. Let me remove it altogether. And what we have done in the last session was we have defined one sample data set, right? Where we have created a data with advertisement, spending, and then sales that we are getting. And then we are building a model to train on this data and then do the prediction on the unseen data. So the code map that we were designing, the first step was to define sample data set. Then the second one was, define features and label. Then train test split is something that we have done, right? And then we have defined the model and we have fitted the uh, train features and train labels, right? That's what we have done. And we have done prediction on X test, which will not be used in this code in the basic flow that we are looking for now. So we will make use of it once we will study statistics in today's class. And once we will understand the performance evaluation metrics for regression problem types, then we will, make use of this particular prediction that we are doing on the test data set. And we have created one sample new data where I have kept only one value. Last time I have entered 2, 3 values, right? So let's keep it one value only. So we have trained our model and we want to know that on advertisement spending, if we are doing $11 or 11, whatever is the unit you want to keep, then what should be the sales that I'll get out of it? So this is something we want to see. Okay. So let me run this program and see what prediction this model is giving me. Okay. So it is predicting 10.89, whatever unit you want to give. Let's keep, let's keep the unit as dollar. That means that when I'll spend $11 on advertisement, then my prediction is that I may get the sales of $10.89. Okay, so this is the uh, basic usage of simple linear regression. Okay, now we want to form the final mathematical equation that will form, right? So in order to find final mathematical equation, okay, so this is the equation that we have seen, right? Y equal to I, which is intercept, plus C1 X1. This is for this is the equation for prediction. This should be Y cap, right? This is how we used to form a linear equation for simple linear regression. So why it is simple linear regression? Because we have only one feature, X1. We don't have more features. So the equation that we will form will somehow, the mathematical equation that we will, finally form will somehow look into this particular format. Okay. Y equal to I. I is what? I is intercept. So this is intercept. And C1 is the weight or coefficient, right? Coefficient. Now to form the mathematical equation, we have to basically calculate intercept, value of intercept and coefficient. And we will be able to do that once the model is trained. So once we train our model, we will be able to extract out all these informations. Okay. So first, let's see, we are, extracting out the intercept. So intercept will be model dot intercept underscore, and then coefficient will be model dot coefficient underscore and zeroth coefficient. So we have only I mean one coefficient. So at zeroth index we will be taking it. And let's put some print statement. Um, okay, let's print intercept and let's print coefficient. And then we will finally uh, form the mathematical equation. Okay, so let me print one statement as final mathematical equation after training the model. Okay, how do I form the equation, final equation? So let's form the final equation. So the final equation will be print. Okay, so we will be using f string here, f string, because we will be replacing some values, right? So final equation may, what is the y cap? It is the sales, right? So let's keep the name of the variable as sales. Sales equal to, first is I plus C1 X1 we write na. So first we will be writing I, which is intercept, right? So intercept, and we want to keep the intercept to two decimal places after point. So we will write 2f, okay? And then we will write plus symbol, and then we will be writing coefficient into, so coefficient into this C1 X1 we want to write. So what is C1? C1 is coefficient, and we want to write the coefficient to two decimal places. So 0.2f into C1 X1. What is X1? X1 is advertising. Okay. So let's run this first and we'll see how the equation forms. Okay. So the final equation forms like this, right? So this is the equation that got formed when our model I mean, when we trained our model on the data set, and it has find out some pattern out of it. So you can see clearly, right? It is looking into this formats, y cap equal to I plus C1 X1, correct? So what is y cap here? Y cap ki jagah we are calling it as sales, because sales is something that we want to calculate. Intercept value is 2.9, so we are writing 2.9, and then plus symbol is there, right? C1 is coefficient, C1 is 0.95, and advertising is the feature, so input. So instead of writing X1, we are directly writing advertising. So this is how you form the mathematical equation when you train your model on the sample data sets. Okay. Any questions, any doubt before we move forward? Okay. Now let's see. So yeah, someone is saying something.
Yeah, can we premise concept and coefficient before we train the model, before the model dot fit, just to see that these values are getting changed?
You want to give some other
Print the
values to see
no,
whether it,
no, 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 no. Let's copy and paste the line number 36 and 37 before model dot fit.
this one, okay, 36 and
Before,
37.
no, not 36 and 37 will not be sufficient. We need to assign those values as well. From 34 to 37, can we copy those values and
Hmm.
paste it before model dot fit?
Model dot fit. Okay.
Just to see that the values that are after trying, these
Hmm.
values are getting changed.
Yeah. Okay. So I'm running it. Either pay I have just commented out. Okay.
Okay.
Okay. So it has not
Not
able to
assigning
identify
value.
intercept, because without training it, you cannot, because after training only it will be able to calculate the intercept. So that is why this error is coming. So after fitment only you will be able to do that. Control Z. Okay, cool. Now, so we have seen the basic flow of simple linear regression. Now, let's um take an example of multiple linear regression where multiple features will be there. And our equation will be of this format: y cap equal to I plus c1 x1 plus c2 x2 plus c3 x3. ठीक है, let's take three inputs, and finally we will train our model and we will form our equation in this format. Okay, so let's before that, let's create a code map for that. Okay, so code map will be same, right? That what we are doing, but yeah, let's do that again. Okay, so zeroth step will be necessary imports, correct? First step will be to create sample data set. Okay, second step will be define features and labels. Third will be train and test split, correct? Fourth will be define model. Fifth will be make prediction. Again, this will not be useful that much, but yeah, let's go in a standard way. Sixth will be predict on new data set. And seventh will be form the final mathematical linear equation. Okay, with intercepts, coefficients, and we are taking three variables, right? So three and three input variables, something like this. Okay. Now let me copy this and let me create one more file. Uh, of advertising multiple linear regression Python file. Let me copy it and comment these out first. Okay. Necessary imports will be taken care automatically. Sample data set. Let's create a sample data set. Okay. So what kind of data set I'll be creating? I'll just give you an example. So यहाँ पे three variables I'll take, and fourth will be the label, right? So यहाँ पे this will have TV, the amount that I will spend in TV advertisement. This will be the amount I will spend on radio advertisement. This will be the amount I will spend on advertisement of newspaper advertisement. And then the final column will be the sales column, that the sales that I'll be getting. So I'll give you one example in this. Let's say I'm spending 230 something to $30.1 on TV advertisement, and some 37.8 on radio advertisement on and newspaper, something like 69 point something, let's say, on newspaper. And then I'll be getting some sales out of it, so 22.1. So what this data denotes is that I am spending this much amount on TV, this much amount on radio, and this much amount of newspaper advertisement, and I'm getting this much sale, and I'll be having a lot of data. Now what I will do, I will train my model on this data, and definitely what I will do, I will split this data into train and test, correct? So let's say when I'll split on this train, so ये वाला this particular portion will be known as X train, and this particular thing will be known as, here in this case, Y train. And similarly, ये test वाला whatever is there, this will be known as, this much data will be known as X test, and this data will be known as Y test. Okay. This I will do like this, something like this. And my aim is, so I will train this model, I will form the final mathematical equation, and then once I'll form the final mathematical equation, I have to find out which particular mode of advertisement will be, highly recommended for me, which particular mode of advertisement is something which I can, altogether stop doing it because I'm not getting result out of it. And what are the baseline sales? I mean, the what are the factors which affects the baseline sales? So these are some of the data analysis, data analytics that we will apply on the trained model and on the final equation that we will get. Okay. So we'll do these data analytics later on once we will form the final mathematical equation. Okay. So let's start, doing the coding for it. So first example, so I will be taking some random data. Random data will be in the form of dictionary, and dictionary may the columns that I have shown you. So first, let me take TV advertisement data, or just let me name it as TV, and let's take uh, 10 values. Okay, so I'll just write down these 10 values randomly. What is it? Let's take 180.8, 8.7, 57.5, 50.2, 8.6, 199. Okay, so these are 10 data. This is the advertisement amount on TV advertisement. Let's take next mode of advertisement, which is radio. Let's again take 10 values. Okay, let's do one thing. I will copy. I'm just checking whether I have these data somewhere copied. Okay. Let me copy this data, huh? I don't have to repeat it, otherwise it will take a little bit more time. Let me copy this data. Okay. So I have taken 5 data, which is TV, radio, newspaper, sales. Now, what is the next step that I have to do? I have to convert this into data frame, right? Convert Python sample data dictionary into what? Into data frame. Data frame, how do I do that conversion? Using pandas library, right? So df equal to pd dot data frame and data. PD is something which is yet to be imported. So uh, let's import pandas as PD. So I have converted my data into data frame. What is the next step? Define feature and labels, right? So feature के लिए we will be using capital X. Why we are using capital X? Because capital X represents 2D matrix. Y is represented into lowercase letter because it's a one dimensional matrix, and in matrix the naming convention is that 2D matrix are represented by uppercase character and 1D matrix is represented by lowercase characters. That I have already told you before also, right? So X, it's a 2D matrix, so 2 square bracket at the starting. So out of these, what will be the feature? One feature will be TV, another will be radio, and then newspaper. So let me define this. So it will be TV, radio, newspaper, sales is not. So I have defined my feature. Now let's define the label. So label is sales. So I have defined my feature and labels, right? Next step is to do the train and test split. How will I do the train and test split? Again, I will use X train, comma, X test, comma, Y train, comma, Y test, something like this, multiple assignment in single line. And then I'll be using train test split method of sklearn dot model selection. And here I will do, here I will, pass on the arguments X, Y, test size. Okay, X, Y, test size and random state. So random state is something you can give any number here. So 1, 2, 3 they have given. I can give 42 also because 42 is a standard value that people give in random state. What does random state signifies is that for any particular number, the way in which this model will split the test and train data in 80 to 20, 80% train, 20% test data. So shuffling and then selection of the final train and test data will be in a particular pattern, right? So this 42 number describes one kind of pattern. If I'll give 43, it will be another pattern. If I'll give 44, it will be another pattern. So that pattern is for internal usage of this particular division, which we are not bothered as of now. So you can give any number. So we can give 42, which is a standard way of giving the random state. So this is how we divide train and test data by using train test split function. So we have done this split. Next is define model. Okay. So let's define model equal to linear regression model. And then next line is train the model. So we will do model dot fit. And what I will train on? I will train X train and Y train, whole data that I have taken for X, train data set, right? Okay, so linear regression, this is not yet imported. This is the wrong linear regression imported. It should be sklearn dot linear model. Linear model. Okay, this is correct. Okay, now we are good. Okay. Now next step is make prediction. So we will be doing the prediction on test data set. As of now, we are not doing with this YPRED, but once we will learn the statistics, then it will be useful. So we'll see it later on. Predict on new data set. Now, in order to predict on new data set, let's define a new data. Okay. Let's define new data, something like new data equal to PD dot data frame and okay, let's pass some new data. Let's pass TV ka data, TV, and we can predict on more than one data also, more than one new data. So let's take couple of datas here on which we want to do prediction, not just one data, right? So let's give the value 250 comma 150 comma 300 radio. Radio ka generally we have given 2 digits, right? So let's give 40 and then 20 and then 50. Newspaper 60 28. This is fine. Okay. So we have taken the new data. New data needs to be okay. It is already, we have all okay. PD dot data frame directly converted. Okay. Now the new prediction will be new prediction. Predictions will be model dot predict on new data, correct? So let's print these new prediction, print new predictions, new prediction, okay. And yeah, before we form the final mathematical linear equation, let's run this program and see how it works. Okay. I have to run current file. Let me run it again. Okay, so new prediction is it is showing new prediction, right? So first data. So first data, how is it looking? I mean the data, how is it looking? The first one. Okay, so we have provided the data something like this: TV, radio, newspaper. Okay, so TV का we have given 250, radio का 40 and then newspaper का 60. So this is first sample of new data, right? Second sample, what is the second sample? 150, 20 and 20. What is the third sample of new data? 300, 50 and 50. ठीक है. And we have given the data and we have asked to predict the sales for these data, right? Prediction. So we will be having three prediction: blank, blank, and blank. Three blanks, right? So the first prediction came out as 20.77. Second prediction came out as 54.49. And this third prediction came out as 9.02. So this is how the prediction is happening. So for new data also, we have provided more than one samples, and we are predicting this new data in a shot, right? All together. So this is the prediction that is happening for the new data. Now let's form the final mathematical equation and then we'll do the data analytics part after that. Okay, so we have to form final mathematical equation. For final mathematical equation, what I require is intercept, right? First thing. Uh, okay, intercept. Directly let me print intercept equal to model dot intercept and print coefficient equal to model dot coefficient. I will do तो यहाँ पे coefficient we should be having three coefficients, right? C1 comma C2 comma C3, right? Three coefficients should be there because we have taken three features. Now let's print the final equation. Um, mathematical linear equation after model training. Okay. So it will be, let's print it. Okay. So we will start with y equal to, so y की जगह what we will give, we will start with f string. We will give sales, right? We want to calculate sales. So sales equal to y equal to I plus I. So first thing is I. I means model dot intercept, correct? Model dot intercept I have to print and I have to print, let me take it till two decimal places. So I is printed. I plus, next thing is plus C1 X1. So C1 X1. So what is C1? C1 will be model dot coefficient coef underscore, and it should be the first coefficient, correct? Sorry, at zeroth index. So this is C1 and into I have to put into what is the X1 TV here, correct? Okay. नहीं इधर पे नहीं, here I'll do TV. Okay. So this is first, and then similarly I will do for radio and newspaper also. So let me copy this, paste these two times. यहाँ पे let me make it as one. और यहाँ पे I will make it as radio, and here let me make it as 2, and this should be newspaper. So this should display my final mathematical equation. Let me run this. Let's see how it is forming or how it is coming. Yes, it is coming. This particular uh, equation is coming up, right? Now, what does it basically denote? So it is coming as y cap equal to I plus C1 x1 plus C2 x2 plus C3 x3. Correct. This it's coming it's coming up in this particular format. Now, if we'll look towards coefficient, so this is a very low coefficient. This is minus coefficient. So minus coefficient, what does it denotes? So it denotes that increase in radio spend reduces predicted sales slightly. So it means that the radio spendings or the radio advertisement amount that we are spending do not have real effect because it is negative. And this is also negative, but this is more negative, minus 1.3. This is minus 1.3 is there. So it means that radio spendings, whatever we are doing, is not helping us at all. Newspaper wala is also not helping, but comparatively, radio and newspaper radio is more negative. So we can say that radio has the least impact on the sales, and we can remove the advertisement on radio because our model has predicted this amount. TV spending is positive, although this positive number is not that great, but still, this what do you say? The amount that we are spending on TV is somehow, increasing our sale because it is positive. So this is how we do analysis. Let's take one more example where let's say the final equation comes something like sales equal to, let's take intercept as negative in this case, 1.55 plus 0.07 into TV plus 0.30 into radio plus minus 0.07 into newspaper. Newspaper. So let's do data analytics on this kind of equation. Let's say if it comes. So first of all, intercept is negative. So it tells, so what does intercept represent? So intercept represents the value when we keep all the features as 0. When we do x1 equal to x2 equal to x3, that when we do x1 equal to x2 equal to x3 as 0, then the prediction, what prediction is basically made when we make all the features to 0 is the definition of intercept, right? It means that in reality, the sales cannot be negative, but this model shows that without advertisement, the sales are very low or near zero baseline. So from this data, let's say the first data analysis will be without advertising, the sales are near to zero because intercept is coming as negative. So intercept, definition of intercept is that the value, the predicted value that comes when x1 equal to x2 equal to x3 equal to 0, then the predicted value, whatever comes, is known as intercept. Okay, so this is the first analysis that we have done. Now let's look on to the coefficient C1, C2, C3. सबसे ज़्यादा, I mean the highest coefficient is C2, right? Which means that radio advertisement is most effective to increase the sales. Correct? This is the second analysis. And C3 is negative, right? C3 is negative. So C3 negative tells us that uh, newspaper advertisement may not help. So newspaper advertisement may not help. And TV ka 0.07, it's very low. It is still positive. So it is meaning that TV advertisement helps moderately, right? Helps moderately. Okay, so this is, so once let's say I have fetched my company data, I have created model, I have trained my model, and I have done some predictions also. And when I form the final mathematical equation, so I have done, my data analytics team has done some analysis, and these are the high pointers of this analysis. And I'll give this analysis, the data analytics team will give this analysis to the company. So based on this analysis, company may decide कि okay, newspaper advertisement may not help, so let's remove the newspaper advertisement from future. TV advertisement helps moderately. Okay, so whatever money we are spending on TV advertisement, let's shift that money to radio advertisement, because radio advertisement is most effective to increase the sales. And without advertisement, the sales are near to zero. So, it's mandatory for us to, carry out the advertisement in future also. So that's how the decisions are being made in the organization. That's how the decisions are made in the industry using machine learning and using the data analysis. Any doubts? All clear? Okay, I'll take it as a yes. Yes, someone is saying something.
No, just saying yes.
Okay, cool. So let's do one thing now. We will have Menti quiz, and after that we'll take a break, and then we will study the statistics. Okay, so everyone please open the menti.com, and this is the code code of today's quiz, which you can see on your screen: 588 422 42. So I'll wait for the players to join, and whoever wins today's Menti, so I'll be putting the Menti champ. I'll suffix the Menti champ with his name. Okay, two players are ready. I can see four players are ready. So I'm expecting to see six players. I'm still waiting for two other players. Kindly join. Menti code is 588 422 42. Okay, five players are ready. One more to join. Okay, I'll give another 20 seconds. Whoever haven't joined, please join. So whoever will win the most Menti quizzes at the end of the course will be awarded with Amazon gift voucher worth 2000 rupees. So please take it seriously. You have the chance to. Okay, Vishant is telling I'm out today. Okay, that's fine. Okay, so let's get started. So I'm starting the quiz. Here comes the first question. So the quiz is on Python modules. Okay, what is a module in Python? Okay, so everyone has answered it wrong. So Python module is just a Python file, right? So any .py file that we see is a Python module. A collection of libraries, no. A collection of modules is known as Python package. A collection of Python packages is known as Python library. Okay, so the correct answer was a single Python file containing code. So no one has answered, so leaderboard should be displaying 0. Okay, let's go to the next question. Okay, 4 players are ready. I think initially we had 5 players, I would say. Okay, five players are ready now. So let's go to the second question. Okay, which of the following is an example of a package, Python package? Everyone has voted. Let's see what is the correct answer. Oh my God, everyone had answered incorrectly. This one also. Okay, so math is a module, right? Math module. Collections is a package, and collections contains counter class, right? That we have seen when we were studying about module packages library, right? So the correct answer is the collections package. Okay. Still 0, 0, 0. Let's go to the third question. Okay, all players are ready. So here comes the third question. Which of the following is an example of a library? OS, pandas, sys, main. Everyone has voted. Let's see what is the correct answer. So pandas is the correct answer, right? Okay, now I can see holy effect is tapering down. First two questions were under the influence of, holy effect, I would say. The correct answer is pandas. Okay, let's go to the leaderboard and see who is leading the charts. Okay, the fastest is Millie. I don't know who is Millie. Okay, let's go to the next question. So question number 4, here it comes on your screen. Which statement is true? I think I have already explained, 2, 3 minutes back only on the true statement, right? Okay, the correct answer is a package contains modules. Let's go to the leaderboard and see the updated score. Okay, so Millie had answered it correctly. Cool. Let's go to the next slide. Okay, so question number 5, here it comes on your screen. Which level is the largest? Package, module, function, library. This is an easy question. Okay, the library is having the highest level because library contains packages, more than one packages contains modules. So that way library has the highest level. Let's go to the leaderboard. Okay, so Millie first, SK second, Mag third. Let's go to the next question number 6. 4 players are ready. I'm still waiting. Okay, 5 players are ready now. So let's go to the question number 6. Where do built-in modules like maths and OS belong? Again, this is a simple question, I would say. Everyone has voted. The correct answer is Python standard library. Let's go to the leaderboard. Okay, Deepak, Raj, and Millie had answered it correctly. Okay, Millie is still leading the charts. Let's go to the last question. Last question. Let's see who wins after this question. So here comes the last question on your screen. A Python file name utils.py is best described as. Everyone has voted. The correct answer is module. Okay, let's go to the leaderboard and see who wins this Menti, today's Menti. Nice. So Millie is the winner. So who is Millie? Please, can you announce yourself?
I am Sai.
Sai. Sai
Yeah,
only.
like yeah, yeah, it came with a default name.
Nice. So last time also you won, right? Congrats. Okay. So today's Menti winner is Sai. And 7th March 2026, Sai Krishna. So I have updated your name, Sai, in the chat. So you are the Menti champ today. Congratulations. So with this, we'll take 10 minutes break. And once we come back after break, so I'll start statistics. Okay. So let me start the timer and see you in 10 minutes. Hey guys, welcome back. So we will be starting with statistics. Okay. Okay. Cool. Now you have to pay a very close attention for this topic. I have tried to keep it very simple for you. So we'll learn it by taking examples. Okay. So let's write down some values. So in this column, let me give the value of y, which is the actual value, right? Actual label value, and then y prediction. Y prediction, y cap. Okay, 1 second. Cap symbol, cap symbol. Caret symbol. Okay, y caret. Okay, this is predicted value. Predicted. Now let's take some, examples in this. Some values I will give. So इसमें let me give 3, 5, 2, 7, and 4. Okay. And y predicted may let me give 2, 6, 3, 7, and 5. Okay. So these are the values respective values. This is the actual column and this is predicted. Means, let's say my actual value is 3, but my model has predicted 2. My actual value was 5. My model has predicted 6. Which case I am talking of? I am talking of training and testing data set, right? On training and testing data set, I have actual values also in my in my data set, right? That I provide my model. It's just that on the new values, I have to predict, new values altogether. But on training and, testing data set, I already have actual values, right? And then after training the model, I do the prediction on test data mainly, but yeah, we can do prediction on the train data also just to find out how my model is working. So that's where this y and actual and predicted value comparison comes into the picture. So let's say my actual value is 2, but my model has predicted 3, and so on. So this is a very simple example that I have taken just to understand various statistic terms and the various terms in statistic that will be used to evaluate the performance of my machine learning model, right? One second, please. ठीक है. Now, first term is mean. So if I will take the mean or the average of these actual values, what is that I will get? I will get mean of actual values, which is 4.2. इसको I represent by y y not y y dash, what do we call it as? Y, okay, this one, y dash, right? Let me copy this. Okay. So mean of actual values is represented by y dash, and it came as 4.2 in this case. So let me mark in red all the important values. Okay. So mean of actual value is 4.2 in this case. Now let's form some more columns. First column that we want to form out of these values is error. So error is defined as y minus y cap. Okay. So y minus y cap is known as error, right? The difference between the actual value and predicted value is the error. So let's calculate in each of these rows one by one. 3 minus 2, 1. 5 minus 6, minus 1. 2 minus 3, minus 1. 7 minus 7, 0. No error in this case. And 4 minus 5 is again minus 1. So this is error. Now next column I'll create is absolute error. It is known as absolute error. What is absolute error? Just the absolute of this value, right? So absolute is defined like this in mathematics, right? So absolute of any particular value is when we remove the negative sign. So it will be 1, 1, 1, it will be 0, and it will be 1. Okay, so absolute error. Now, sum of absolute error. What is the sum of the absolute error? If I will tell the sum of the absolute error, what is the sum here? If I'll do 1, 2, 1, 2, 3, 4. Correct? 4 is the sum. And if I'll take the average here, what will be the average? It is coming as 0.8 here, right? You can see in the Excel file later on. I mean, in the bottom part. So average is, in this case, or directly let me write down as average equal to 4 by 5, which is 0.8 in this case. Now this 0.8, what average that I'm, calculated is known as mean of absolute error, which we call as MAE also, right? Very important term because it is used in performance evaluation metrics. So mean of absolute error. Mean means average and absolute error. Absolute error is something this that we have calculated, right? So absolute error ka mean when we are finding it is known as mean of absolute error. Clear? Okay, let's go to the next column. Let's create one more column where we are calculating y minus y cap ka square. Okay, we are doing the square. So square ka bhi symbol let's copy from internet. Square symbol. Okay, so this is the square symbol. Okay, so this is y minus y cap ka square. So it is known as what we call it basically. We call it as squared error. Squared error. Okay. So this is squared error. let's do the squared error. So it will be 1, 1, 1, 0, and 1 again, correct? Okay. Now in this case, squared error, when I'm doing the summation, what will be the summation of these squared error? 1, 2, 3, 4, right? So summation will be 4 here. Sum is 4. And this term is known as uh, sum of residual sum of squares. So residual sum of squares, which we call it as SS and then RES. SSRES. RES को छोटा कर दो. And then let me highlight this. Okay, so this is known as residual sum of squares. Okay. Right. Next column. Let's go to the next column. So next column is basically y minus. I am taking this mean wala. Okay, y bar. So I am doing y minus y bar. And this is known as, in simple mathematic statistical terms, is known as deviation. Okay. Deviation. So deviation, when I'll do y minus y1, so this is the first value, right? So when I'll do 3 minus 4.2, how much it will be? 3 minus 1 minus 1.2. Then for next line, when I'll do 5 minus 4.2, it will be 0.8, 2 minus 4.2 minus 2.2 and some and so on. So let's write it down. It will be minus 1.2, 5 minus 4.2, 0.8, 2 minus 4.2, 2 minus 4.2 minus 2.2, 7 minus 4.2, 8, 2.8. Okay. And 4 minus 4.2 minus 0.2. So this is the deviation. Okay. Now, next column. Let's call it as squared deviation. Deviation. Okay. Squared deviation. What is a squared deviation? I will just do the square of this value, right? Iska, if I'll do the square, it will be squared deviation like this. Okay. So square deviation, when I'll do, it will be 1.44, 0.64. Next will be minus 2.2 ka square will be 4.84. Every value will be in positive because we are doing square. 2.8 ka is 7.84. It will be 0.04. So this is squared deviation. Now squared deviation, when I'll do the summation of this, summation of this will be 14.8. You can see in the screen here, right? It is 14.8. Let me write it down as 14.8. And this is known as total sum of squares, which is represented by SSTOT. SSTOT and TOT go. Okay. Let me color it also. Okay. So three important terms came basically. Residual sum of square, total sum of squares. Okay. This will be used to find and calculate R square. What is that? I'll come to that. And we have one more term which came up, mean of absolute error. Correct. Okay. Now let's create one more column. and it will be absolute deviation. Okay, absolute deviation is this value. If I'll do the absolute deviation, it will be the absolute value of this value, something like this. And just I'll remove the negative sign. 1.2, 0.8, 2.2, 2.8, and the last one will be 0.2. Okay. And when I'll do average of this, average. So इसका average क्या है? The average is coming as 1.44. Here you can find out average, right? 1.44. So here if I'll write down 1.44, this is the average and this is known as mean absolute deviation. Mean absolute deviation, which is known as MAD, M-A-D. Okay, mean absolute deviation. Okay. MAE is this, MAD is this, SSRES, SSTOT. Okay. Okay, now
Now,
yes.
one quick question.
Yeah.
Here we calculate this deviation, standard deviation, absolute standard deviation on.
No, standard deviation is not yet calculated. I'll tell you how we calculate the standard deviation.
Okay. But why are we calculating it on actual value? Do we need to calculate on predicted value or actual? These
Your
deviations.
voice is very low. Can you? Yeah.
Why are we calculating these deviations, all the deviations on actual values? Or do we need to calculate?
Because see, the actual value are our truth, right? What we
Correct.
call it, the absolute truth. So anything that we are calculating will be calculated as per we keep the actual value as baseline value, and then we find the deviation from that particular value.
Okay.
So the actual value is our source of truth. So from that source of truth, we have to find how much we have deviated. That's why the actual value comes into the picture. Okay. Okay, next concept is coefficient of determination, R square. Square symbol, let me copy R square. So R square is calculated as 1 minus SSRES, which is this value, divided by SSTOT, which is this value. This is how we basically calculate the R square. So 1 minus 4 by 14 1 second, yeah, calculator. Calculator. Okay. So SSRES is 4 divided by 14.8. 4 divided by 14.8 is 0.27 minus 1 we have to do. So we'll take the positive of it, right? So it is 0.72. So when we will calculate from above values, it will be 1 minus 4 divided by 14.8, and which will come out as 0.72, right? Yeah, 0.72. So this R square, this is known as, what do we call it as? Coefficient of determination. So coefficient of determination is known as R square, and this is how we calculate 1 minus SSRES divided by SSTOT. So this is coefficient of determination. Now, okay, let's go to the next part. Okay, so what is next part? So we have calculated SSRES. SSRES Now if we'll take SSRES का mean of SSRES, ठीक है. So mean of SSRES means यहाँ 4 है and then the mean is coming as 0.8, right? This is the 0.8, correct? So when we take mean of SSRES is known as mean of squared errors. So mean of squared error, we call it as MSE. So it is coming as 0.8 in this case. So this is another term. Okay, okay, that's fine. Let's keep it like this only. Okay, so this is mean of squared errors. Now mean of squared error, when we do square root of MSE, so when we do square root of MSE, that is known as root mean squared error. Root mean squared error. That we call it as RMSE. And in this case, it will come out as 0.8 square root of 0.8. What is the square root of 0.8? It will be something like square root of 0.8, 0.89. So 0.89 यहाँ पे in this case, 0.89. And this is known as root mean squared error. Let me highlight this also. Now, important thing that we will be using for we will be basically keeping to calculate or evaluate the performance evaluation. I will just highlight it with a different color. I'll highlight it with a green color. Huh? So this we will be using MAE, MSE we will be using, RMSE we will be using, and then coefficient of determination is something which we will be using. Okay, so these are 4 important things. Now we have more things to discover. Okay, so RMSE, MSE that we have seen, R square we have seen, MAE we have seen, and then MAD also we have seen. Now comes the next part, which we may not be requiring, but yeah, it is always good to know what all these things are. So in this case, square deviation may, let's go to the next step. So next step is when we divide SSTOT with total number of samples. That means in this case, we'll divide 14.8. यहाँ पे 14.8. If I'll divide, how many samples are there? 1, 2, 3, 4, 5. If I'll divide by 5, it will come as 2.96. Okay. Now, when we do SSTOT divided by N, we call it as population variance. Okay. So population variance. इसको भी let me color it nicely. This is population variance. Second thing, when we do SSTOT divided by N minus 1, just one sample less than total sample. That we do in mathematics also. If you remember your mathematic concepts from 10th class, we used to do N minus 1 also, right? So we basically, in this case, the value will be coming as, in this case, 3.7. And this particular thing is known as sample variance. Okay. So this is sample variance. Okay. And square root of sample variance when we do, so square root of 3.7 in this case when we will do whatever value square root. Okay, let's calculate that also. 3.7 ka 1.92. So in this case, it is coming as 1.92. So this is known as standard deviation. So this is about the statistic in a nutshell. Only statistic that you need to learn in order to move forward in machine learning. There are a lot of things in statistics, but I don't want to complicate it. I just want to show you some basics which you should be knowing in order to move forward in understanding the performance evaluation metrics to evaluate the performance of your model that you design. Okay. And okay, one more thing. So population variance ko we basically defined with this sigma, I don't know what this sigma or this symbol. We denote it with this symbol. Sample variance we denoted by S square. So this is something I just want to highlight. And important thing that we need to take care, or that we need to basically use MAE, MSE, RMSE, and R square. These are the four important things that you will be calculating for your model to as a first step to determine the performance to determine the performance of your model. Any doubt before we move forward? Okay, one more thing before I forget. So MAE, MSE, and RMSE. We basically, there is one more term known as MAE percentage, and okay, let me add it here only. So next thing is MAE percentage. If I want to calculate, so MAE percentage will be MAE divided by mean of actual values, which is this value, and then into 100. So it will be for everything, every matrix here, MAE, MSE. So MSE percentages, MSE divided by mean into 100. Similarly for RMSE, RMSE percentage equal to RMSE divided by mean into 100. Okay. So I would say these are more important. I'll tell you why. Let me highlight that in purple color. And coefficient of determination also, let me highlight that in purple color. Okay. Okay, so these are important. Why? Because see, when we are finding the percentage value, so there is one scale that we will form for, good value, average value, and bad value for, MAE, MSE, and RMSE. And when we, play in percentage, then that particular good value scale and bad value scale remains same for all problems. But if we don't calculate this MAE percentage, if we don't divide with mean of actual values, then the scale of good value, bad values, and excellent values will change as per the use case and as per the sample data, as per the data set that we are taking. So always find MAE percentage, RMSE percentage, MSE percentage before you calculate your uh, good, poor, and excellent values. Okay, next step, let's go to the next step. So in this step, what we have done? So we have familiarized ourselves with R square, MAE, MSE, RMSE. Okay. Second step, what we will do? Second step, we will we will learn about acceptable range of R square, MAE percentage, MSE percentage, and RMSE percentage to evaluate whether our model is excellent fit, good fit, or poor fit. Okay. And then third, we will see use cases to decide which matrix out of R square, MSE, MAE, RMSE to focus in order to evaluate our model. Any doubt on what I have written? Okay, one more step is there. Okay, step number 4. Based on the values which we will find, so step 4 is finally you check whether your model is good fit, underfit, or overfit, and then necessary steps to correct that. If it is underfit, then what steps we need to take care in order to fix that underfitting problem. If it is overfit, then what steps we need to take in order to fix that underfitting that we are particularly seeing. Okay, so these are the things that we will see now. Okay, so R square MAE MSC ओके ठीक है range of values. Let's see range of values. So I will write down excellent range here, excellent, good range, and poor range. And first is MAE percentage, MSE percentage, RMSE percentage, and R square. Okay. So this we will see what are the ranges. So let me draw a line and then explain you one by one. First of all, R square, let's take R square. So R square is always less than 1. It is in points and it is always less than 1. And general rule of scale on scale is 0.6, 0.9. Okay. So if it is greater than 0.9, if the range is greater than 0.9, and then range can be between 0.6 and 0.9 also, and then less than 0.6 also. So these are the 3 ranges, correct? So if it is greater than 0.9, it is excellent. If it is between 0.6 to 0.9, it is again a good range. And if it is less than 0.6, it is not a good range. So we define this particular range. This particular range, we will call it as model is poorly fit. This particular range, 0.6 to 0.9, is actually a good fit. Good fit, yeah, good fit. And then greater than 9 is something known as excellent fit. Excellent fit. And now either good fit or excellent fit, that is anything which is greater than 0.6, this both good and excellent combined. We call this range as acceptable range for our model. So acceptable, this is an acceptable range which include good fit and excellent fit. Okay. So this is for R square. We are talking about R square range here. First of all, this is R square. Okay. So let's write down these ranges. So it is greater than 0.9, it is excellent. Good is 0.6, say 0.9, and poor is less than 0.6. Correct? This is the range. Now next range, let's see MAE percentage. What is the MAE percentage ka range? So let's draw a scale. MAE percentage, let's take the value as 5 here and 15 here. So see these three, MAE, MSE, and RMSE. E is coming up here, right? What does E denotes here? E denotes error, right? When we these are the short terms, but when we expand these short term, E is error in all these three, right? So error mein, what is the case in errors? So error is lesser the error, always it is better to have less error, right? So that means ki less than 5, say if it is less than 5, as it is a error terms, error term, right? So lesser is better. So less than 5, it is a excellent range. Between 5 से 15 is one range and more than 15 is one range. So between 5 and 15, it is good fit, and it is good fit, and then greater than 15 is a poor fit, right? So this collectively, this particular range is a acceptable range for MAE percentage, and this is basically this particular is poor range. Now it is opposite to R square, right? R square is not a error wala, so 0.9 means more is better in R square, but in MAE, MSE, RMSE percentage, less is better because error, it represent error, and error, less error is always better, right? So this is the range for MAE percentage. So let's write down this range. So less than 5 is excellent range. 5 to 15 is 5 to 15 is good range, and poor range is greater than 15. Okay. Now let's go to MSE percentage. MSE percentage, when we'll talk about MSE percentage, we'll take 2, we'll take 0.25. Okay, and these are the scales. So lesser is better. So less than 0.25, excellent. 0.25 to 2, good, and greater than 2, bad. So this particular is acceptable range. This is poor range. Okay, let's write it down. MSE less than 0.25, excellent range. 0.25, say 2 is a good range, and poor range is greater than 2. Okay, now let's talk about RMSE. So RMSE. So RMSE 720. So यहाँ पे भी there will be 3 ranges, greater than 20, between 7 and 20, and less than 7. So less than 7, as it's a error term, lesser is better. So less than 7 is an excellent range. Between 7 and 20, again good range, and more than 20 is poor range. So this particular range is a poor range, and this particular range is acceptable range. Let's write it down. RMSE में less than 7, excellent range. Good range is 7 to 20. 7 to 20, and then greater than 20 is poor range. And this excellent and good range collectively is acceptable range for model, and then poor range is anyways, not acceptable. Okay. And these are the performance evaluation metrics. So we collectively call them as performance performance evaluation metrics, METRICS metrics. Okay, so these are performance evaluation metrics. So this is about range. So we have come 2 steps. We have learned statistics. We have, as first step, we have learned about statistics. What are the performance evaluation metrics and how it is calculated internally. Then second step is to know the acceptable and non-acceptable ranges for these performance evaluation metrics. Now, when I was talking about MAE percent and regular MAE, right? So we have calculated percentage here rather than regular MAE. So the importance of calculating percentage is that this range is almost, this will be almost, standard ranges in all the use cases. But if we would not have calculated percentage and directly if we would have, studying the range for ME, MSc, RMSc instead of percentage, then those ranges change, those range changes as per use cases. But when we are finding the percentage, because we are dividing by the, mean values, right? So it will slash down the range for every use case within these limits. So these are the standard limits. These limits can change from project to projects and then company standards to standards. But usually these are the standards that we follow in order to decide the acceptable and poor range for your model based on these performance evaluation metrics values. Okay. Second step done. Now third step. Okay, इसको मैं let me rename it 1, 2, 3, 4 something like this. So this is 1 statistic. Range of value is second step. So this is 2. Third is use cases for deciding performance evaluation metrics. ठीक है. Let me write down the cases. Case and best metrics or metric to focus, and then reason. We will write down these 3 things. Okay. Metrics. Case 1. When we have to take care that prediction must be very accurate. So the accuracy is the foremost criteria. We cannot afford to have a model which have less accuracy. So use case here goes like prediction must be very accurate. In that case, the best metrics to focus is MAE, mean absolute error. Why? Reason? Because mean absolute error reflects the average error, right? Mean of absolute error we are taking here, right? Because it reflects the average error. So that's why the cases where prediction must be very accurate, we must be focusing on MAE. Now, second case where big errors are especially bad. Big errors का मतलब है dollars, when you are playing in dollars, right? When your company is at stake, where a lot of investment is being made, and big error, basically, if you make big error, you may eventually lose up. You may eventually basically end up in losing million of dollars. In those cases, big errors are especially bad. In those cases, the best metrics to focus is MSE. Why MSE? Because it penalizes large errors more due to squaring. So we are doing square, mean of squared error is what we are doing, right? So error is there, and then we are doing square of the error, and then we are taking the mean, right? So as we are doing the squaring of error, so if some error is there, let's say if error of let's say 8 is coming up, and when we are doing the square, so 8 ka square is 64, so it penalizes large error, right? अगर वहीं पे if we have error of 1, if we are squaring it, it is coming as 1 only. 2 है, या let's say if error is in point 2 है, तो point 0.04 हो जाएगा square. So the reason is it penalizes large errors more due to squaring, right? Due to squaring. So what is the benefit that we get out of this? It basically highlights big mistakes. So that is why where big errors are especially bad, we focus on MSE. Now, third case. So we want a quick idea of overall fit. When we want the quick idea of overall fit, then R square is best. So generally when we are learning about machine learning, so this is where we basically focus R square. We mainly focus on R square. Why? Because it explains variance. Okay. Now fourth case, where you want average error plus you also want to consider large mistakes basically. So here in this case, we basically focus on RMSE because it basically mixes up or combines the power of MAE and MSE properties. So these are the quick book of rules to follow if you want to decide on which metrics you want to calculate when you are designing your model, right? And if you are not able to decide on what to pick, so first pick should be R square or RMSE. Out of these two, you can pick any one. Okay. So this is about the third step. So we have learned statistics. We have learned what are the good and bad range of values, and we have learned on use cases for deciding performance valuation metrics. Fourth step is check for good fit, underfit, and overfit. So GUO I am writing. Okay. So यहाँ पे let me make few columns again: range, gap percentage, and model fitment. And these are very important steps that I'm showing you. You will not get these steps anywhere, even on internet if you try to search it. These are the filtration result of my extreme research that I have done in this area to simplify how you basically evaluate the model fitment. Okay, cool. Okay, so let's talk about the range. So you might have noticed, right, when we were calculating or building our model, whole sample data set ko we have divided into two parts, right? ये हमारा these were label and these were features, right? X1, X2. Let me write it down like this. And we have divided into train and test data set, right? So this one we used to call it as X train, and this one we used to call it as X test, and this one Y train, and this one was Y test, right? So we basically do prediction, and then we basically do prediction. यहाँ पे भी we basically used to predict. We will do the prediction later on, and these prediction that we will do. Okay, prediction wala bhi, let me make one more column prediction wala. So that prediction, one second. Let's make one more column prediction wala, and this one will be basically known as, this particular thing will be known as prediction on trained data, prediction on trained data, right? And यहाँ पे when I'll do the prediction, it will be known as prediction on test data. Okay, right? So this is something which I want to show you so that you have clear picture in mind. So these are the things that we will calculate in our model, and we will be once we will do the prediction on test data and trained data. So y and y prediction means this comes into the picture. As soon as these two things comes into the picture, so do our R square and then MAE, MSE, RMSE, it automatically comes into the picture, right? Under the hood, we can calculate all these values, right? RMSE also. R square, ME, MSE. As soon as we are doing prediction on the each of the samples, right? So R square, ME, MSE, RMSE on train data set, and then we will calculate R square, ME, MSE, RMSE on test data set. Both we will calculate, correct? Now, uh, now let that ranges that I'm talking about the range of performance evaluation metrics on train and test data set. Okay, any doubt in that? Simple, right? Now, first condition says that if train data set, both train and test ka whatever we are finding, both are in acceptable range. What is acceptable range? Whatever metrics we are focusing, R square, MAE, MSE, RMSE. So we will calculate on train data set, we will calculate on test data set, and we find out that for both train and test data set, the range of value for whatever metrics we are selecting is coming in this particular range. If we are selecting R square, then if both for train and test, it is coming in this range, that means acceptable range, right? So in that case, if gap is less than 10, and if gap is, okay, if gap is less than 10, and next is if gap is greater than 10. If gap is less than 10 between train performance evaluation matrix and test performance evaluation matrix, we will call our model as good fit. If gap is greater than 10, we will call our model as borderline good fit. Okay. Right. So this is the first case. मतलब ये है कि if we will basically compare it with real world example. So a person is training. I am preparing for exam, right? And I'm preparing for exam. I'm practicing for MCQ, and when I'm practicing for MCQ, I'm able to answer all my questions correctly. So my answer of those questions is in a acceptable range. That is first case. Second case, when I'll go to exam, that is my test phase, right? In exam, whatever question comes, I answered it correctly, and the number marks that I scored is also in acceptable range. So training is acceptable range, test is also in acceptable range, and if the gap between train and test score is less than 10, I will say that okay, I have achieved good thing, or it is a good fit. If gap is more than 10, for example, in training, I have scored, let's say, 90% mark, but in test, I am scoring 70% mark. So here, range is greater than 10, right? Although I have, I can say that training may it was more, but test may it fell down. But still, it is a good fit, right? So I can say, okay, it's a borderline good fit. So this is the first case. Now let's go to the second case. Second case says that if both train and test are in poor range. So poor range, when poor range is there, any gap is means gap will not matter. So I can write it any gap here. In that case, I can say that my model is underfitting here. Okay, and what we have to do when the model is underfitting, I'll come to that later part. So both train and test pay, when we are finding the performance evaluation metrics, both are coming in poor range. So it is underfitting. Matlab, when I'm practicing while studying for the exam, I'm not able to answer the MCQ, the practice MCQ. Even in the test also, I got failed. So gap doesn't matter here. So I will say I am underfitting. I was not prepared well, right? So underfitting. Third case, when train data set comes in acceptable range, but test data set comes in poor range. Okay. What does it mean? When I was practicing, I am able to pass my MCQs, practice MCQs, but test may, when I performed in the test, I was not able to pass the test. So यहाँ पे भी there will be two gap, less than 10, gap is greater than 10. If it is less than 10, I will say borderline fitting. Matlab, okay, so in borderline not fitting, sorry, borderline overfitting, I would say. Means this can be accepted, You can think this as a condition where, let's say, I am practicing for my exam, and in MCQ I'm getting good marks, let's say 90%, 80% I'm getting, but or let's say I'm getting 65% there. And when I gave the exam passing marks is 60%. But in exam, I got for 58 or 59, right? So gap is less than 10. So I can say, okay, it is accepted. So sometimes teacher, if you are scoring 58, 59, they will just, mark you as pass only because you are borderline overfitting there. So these kind of cases, they can be accepted. Models can be accepted in case of borderline overfitting. But if it is greater than 10, let's say in exam you have got 50. So your teacher will not make 50 say directly 60, right? They cannot make. So that's a typical condition of something known as overfitting. So this is the case of overfitting. Okay, last case. When train wala performance evaluation is in poor range and test wala is in acceptable range. Matlab means, and here also it is any gap. Any gap means you were practicing for MCQ. You have practiced a lot of MCQs and you have scored failing marks every time, 20, 30 marks. But in exam, you have passed, right? You have scored 90%. Then there is some ghapla, right? You might have cheated in the exam. That is why, because when you were practicing, you were not able to score good marks. Your training score is poor. But in test, it is in acceptable range, means you have done some ghapla, right? So that particular case is known as unusual case. It doesn't happen. If it happens, then we have to take some necessary measures in order to do that, in order to fix that. Overfitting and underfitting में क्या करते हैं? What do we do in case of overfitting and what do we do in case of underfitting? So underfitting में when underfitting is there, then means you are not well prepared. So in that case, you have to increase model complexity. You have to basically upgrade your preparation material. If I'll compare it with the human analogy, so it is like increasing model complexity. Matlab, if you are using linear model, then you should be using polynomial model. If you are using shallow decision tree, and if it is underfitting model, go ahead and try using deeper trees. If you are using shallow neural networks, go ahead and start using deeper neural network if your model is underfitting. Next step that you can do is add more informative features. So these are some of the basic steps that you can do in order to handle the underfitting. Overfitting, when overfitting comes, then what are the steps that you will do? So add more samples in that case. Add more samples, matlab if your data set has, let's say, thousands or 1500 samples, then try using 2000 or 3000 samples. So you have to add more samples in case of overfitting. Matlab ki training, when you were giving training, so in that case you were able to pass your MCQs, but in test you failed, means you have to add more books to study, so that in test you will be able to handle all those questions that are coming, right? It's because you haven't studied properly. That's why whatever you have studied, you were able to answer when you were practicing, but it's not enough for you to pass the exam. So in that case, you have to add more samples, means you have to add more books to study. So add more samples. Remove irrelevant samples. Irrelevant samples. That is one more step that you can take. And then there are something known as CV and hyperparameter tuning. I don't want to bring it up right now. But yeah, so these are some of the basic steps that you can do in order to handle overfitting and underfitting. Now, in our next lecture, what we will do, we will build a complete regression ML pipeline. And what we will do, we will calculate MAE, MSE, RMSE on training and test data set. We will build the logic to find out the range of value, whether the range of value is in acceptable or non-acceptable range. Then we will decide on which particular performance evaluation metrics we will focus on in that particular Python code. And then finally, we will check whether our model is a good fit, underfit, or overfit. Okay. So once we will handle all these steps, then we can, when we will implement these steps in our model building, then we are basically, we can say that we are building the complete machine learning pipeline for regression use case. Okay. I think enough of theory and enough of concepts. So any doubt, any feedback? These are some of the very complex topics in machine learning. And main thing is that if you are learning these in a organized and structured manner, then only it will be bringing more clarity to you. So any doubts, any feedbacks on what we have studied today? Anyone? Okay, cool. I think Vishant is saying something, but yeah, I think he has some issues in his audio. Cool. So let's meet tomorrow. We will build complete ML pipeline using all these 4 concepts or all these 4 steps, and we'll see how we basically build the complete ML pipeline. Cool. Thank you, everyone. Thanks for dialing in. Have a nice day ahead.